Learn like a pro.
Today, we're going to decode the invisible rules that literally build our entire physical world. We're talking about the architecture of matter itself. Okay, let's just jump right in with a super simple question. We've all seen an ice cube, a puddle of water, and steam. They're obviously different, right? But why? I mean, what really makes a solid so solid and a gas so, well, gassy? The answer, it turns out, is hidden from view on a scale we can't even imagine. And here's the core idea. The invisible dictates the visible. Think about that. Whether it's the desk you're sitting at or the air you're breathing, those properties aren't just there. They're actually large-scale echoes of some tiny, microscopic rules playing out. So what are these super powerful, invisible rules? You might think it's going to be incredibly complicated, but it all comes down to a single, really elegant theory. So in this first part, we're going to pull back the curtain on that fundamental theory of matter. It's called the kinetic particle theory. And honestly, it's beautifully simple. All it says is that everything, and I mean everything, is made of tiny little particles. And these particles, they're not just sitting still. They are always constantly in random motion, just buzzing with kinetic energy. And what's so great is how this whole huge idea just breaks down into three simple pillars. First, composition. Everything's made of particles. Got it. Second, energy. These particles have kinetic energy. And third, motion. Because of that energy, they're always on the move. That's it. That's the foundation for everything we're about to talk about. Okay, so with that foundation in place, now we can look at the actual architect's blueprint for matter. Let's see how these particles are really arranged inside solids, liquids, and gases. First up, solids. Take a look. The particles are packed into this super tight, orderly, repeating grid. The forces pulling them together are so strong that they can't break free and go for a wander. All they can do is just kind of vibrate in their fixed spots. And that is exactly why a solid has a fixed shape and volume. Now, let's see what happens in a liquid. Here, the particles have a bit more energy. The forces holding them together are still there, yeah, but they're more moderate. This lets the particles break out of that rigid pattern and just slide right past one another. It's why water can flow and take the shape of any glass you pour it into. And finally, we get to gases, and here it's just chaos. The particles have so much energy that they've totally overcome those attractive forces. They're just zipping around at high speed all over the place, with huge amounts of empty space between them. And this is why a gas will always expand to fill any container you put it in, no matter how big. This chart just lays it all out so clearly. Just look at the pattern as you go from left to right. With solids, everything is regular, packed, and strong. But as you move over to liquids and then gases, you see this amazing progression, right? The arrangement gets random, the distance gets bigger, the forces get weaker, and the motion becomes way, way freer. So, and this is the important part, this isn't just some abstract theory. It has real-world consequences that explain stuff we see every single day. Like, for instance, why can't you squeeze water? Which brings us to a great question. We have this knowledge now of this tiny, invisible world. So what? What can we actually do with it? How does it explain the way things around us behave? And here is that aha moment. Check out these pistons. In a solid or a liquid, the particles are already squished together so tightly there's basically no empty space to push them into. But a gas? Oh, a gas is mostly empty space. So compressibility, the ability to squeeze something, it's all about that microscopic emptiness. So we've seen the structures, but now let's talk about the engine that drives all the change. What actually transforms matter from one state to another? This is the journey from structure to chaos. So what's the one thing that fuels these incredible transformations? What turns a rock-solid block into a flowing liquid and then into a wild, chaotic gas? This secret ingredient is just energy. And this final graph, this brings it all together beautifully. Look, on the bottom we have kinetic energy. On the side we have the attractive forces holding particles together. See what happens? As you add more energy, as you move to the right, you start to overpower those forces. You go from the rigid structure of a solid to the fluidity of a liquid, and finally to the total chaos of a gas. It's all just a constant battle between energy and attraction. So the world we actually see, solid, liquid, gas, it's all built on this invisible dance of particles, governed by a constant tug of war between energy and attraction.
And if a few simple rules can explain all of that, it really makes you wonder, what other invisible forces are shaping the world around you right now?